Okay, so we had gone over lists in this module, took a little break to talk a bit about while loops. Now we're going to return to lists and talk about manipulations using these list objects within Python. So here we have a list defined. We can then create a shared reference where we just say assign the value of A to B. Pretty easy. So it's really saying A and B are two separate variables, but they're really just the same list, 1, 2, 3, 4, 5, right? So what's going to happen if we do something like this? If we say, let's retain that first element of the list B, replace it with the value 999, what is A going to be? Well, interestingly enough, because this is what we call a shared reference, this is going to also substitute that value. So this is maybe not what you would intend, I assume. So in order to avoid this shared reference behavior, a second list needs to be created. And so you can use the so-called slice syntax to create this new list and then prohibit that shared reference. So rather than A and B both pointing to that reference, which then points to 1, 2, 3, 4, 5, we create two references. So it's now two lists, two verifiable lists. So if we then replace the value of the first element of B with 999, it only does so for the B element or B list. Notice the only syntactical difference is using the slice syntax, and it involves a little bit more coding where we just have to use those square brackets and colon. So let's make sure we understand this. Here's a list. So we've got actually two lists within a list. That's A. Then we avoid using shared reference by using the slice syntax here. So A is pointing, B is pointing. They make some reference, but notice some differences here. The picture indicates the state after the code executes. So if we then run the following, append B, append 8. So the idea is that we be appending the element 8 to B. What's it going to be? Okay, I stopped there and I realized it was truncating cutting off the bottom of my slide there. Test the code, perhaps. Think about what it's going to be the necessary, how do I say, structure for this B element. And what is the list then referred to by A? Maybe do a little exploration. Let's talk about this in class and make sure we understand. Because there's a lot of questions going on here that I want to make sure we talk through together. But go ahead and choose your answer and we'll review. Okay, so we can concatenate and repeat elements to create list objects that maybe refer to others. This is a really useful kind of technique to use when you're dealing with lists that may be returning elements of another list and things. So the plus operator is, again, overloaded to operate on two lists. It'll return a new list and result, it is just concatenation of the right-hand list to the left-hand list. So whatever's on the right-hand side gets concatenated to the left-hand side, in other words. It's similar to the extend method, but extend doesn't return a new list. So keep that in mind. That actually refers back to what we kind of like what we did here, right? So let's go ahead. We're going to test this out in the notes, but also spend a little time exploring this before you come to class. Also, the asterisk operator takes the list at L and an integer N, and then it creates a new list by copying copies of L using that plus operator in -1 times. So it's just going to repeat. It's like rep or replication in R. So let's take a look at some and talk through these examples. Here we have list 1. List 2 is going to be list 1 plus list 1. All right, so that's easy enough. We have 1, 2, 3, 1, 2, 3. Then we're going to take the first element, really. I think I said the first element before. That's my R brain speaking. And replace it with the value 99. Notice list 1 is not going to be modified because we've actually created a new list in this step. So it's not that shared reference anymore like we started off with in this set of slides, but instead is creating a whole brand new list. So that's good. However, let's look at this code. List 1 is again 1, 2, 3. Now we're going to take list 1 plus list 1. Notice the syntactical differences. Then we're going to say, let's replace the first element in here. I don't want to give it away. I'm having a hard time saying this. Try this out. Then take a look at list 1. It's going to modify list 1. Make a prediction first. I'm having a hard time explaining it without giving it away. So make a prediction about how you think list 1 is going to be modified, but it will be modified. And think about what's happening right here. Why are we using these square brackets in this manner right here? And how does that then affect list 2 and then correspondingly list 1? So take a moment, stop it, stop the video. This is, again, another case where you just need to type and experiment a little. Okay, range, I think we've used this before, but this is the first time we'll talk about it more formally. It's just going to generate sequences of integers. It's very useful. You end up using it all the time. If you say range in, where n is some whole number like 5, then it's going to create the integer 0 to 4 in that case when n is 5. If we call instead range mn, it's going to create integers from m to n minus 1. So we can have a start and stop. Otherwise, if a start isn't referenced, it just assumes it's the 0th element. Instead, we can make it even more complicated. We can have the start, m, the stop, n, and then s is going to be the increment. So we can go by 5s, we can go by partial decimal amounts, anything. If you use list, range with whatever of these 3 version arguments you want, it'll convert that range object to a list. So it's easier to handle or look at in some cases. So what's going to be the result of this? Take a moment. Remember, this is the m, the start, the n, the stop, and the increment. Make a prediction. You may think it's possible that there are 2, because notice the increment goes 2, 5. So I think I'll go ahead and say 2 to 5 is for sure, right? But then you add another 3 and you get 8. So will it include the 8? Will it not? Will it substitute in the 7? Make a prediction and test it out. What about this one? 4 up to 9 by 4. Think about, based upon what you got before, what you think is going to happen this time. I think this one will be easier. Okay, you can use for loops to return a function, or to write some kind of function that returns a list containing your string in all uppercase. Okay, so this is pretty simple to do with the for loop. Okay, so given a list of strings, so you have a list element with a bunch of strings, you just write a function that returns a list where you've converted everything uppercase, not class. There's another way that we're going to take a look. Given a list of strings, write a function that modifies the list so that all the strings are in uppercase, but don't return the list. So notice the difference. In 1, we don't modify. In 2, we do modify, but don't return. By the way, this does not work. So here's a function. Notice we just call it uppercase list. And here's our description. Here's our for list, and here we're converting everything to upper. So this might be your first thought, but this is actually not going to work. Think about why, and we'll talk about why. This, by the way, we'll work on in class. I was going to spend some time in the notes, but I already see I'm running long, and I think this is a really good class exercise. So final slide here. What's printed by the code? This one we can think through, I think. We have a list. We have a sum and counter initialized to 0. Then we have a while loop. While the counter is smaller than the length of list is going to be what? 3. Then we increment sum by counter. We increment counter by 2, and at the end we print sum. So we're going to stay in this loop here. So remember, because of the indentation, we know that's the contents of the loop. We're going to stay in this loop here until counter is bigger or equal to the length of list. So go ahead and take a moment. If you want to test out the code, just pause the video. Otherwise, we're going to go ahead and make a prediction. Okay, so last part here. I accidentally took my, there you go. Let's talk through this code. While the counter is smaller than length of list, so 0 works, then it gets incremented by 2. What's happening to sum here? Well, counter is 0, so sum is still 0. Remember, this is not within your while loop, so we're still within the while loop, so we haven't encountered the print statement at this time. So then counters 2, it's still less than length. We will increment sum to 2. Counter becomes 4. We evaluate the while condition again, but it is no longer less than length because now counter is 4 and the length is 3. So we will go to the print statement. We should get 2. Try this out. I think that logic is correct, but try it out. Okay, so we'll pick up here next time. I think this will give you enough material to get our next assignment done. I'm going to try to include some of these manipulations within your next homework.